The topic is quadratics. Or quadratic equations. Okay? And today is January 21st, 2021. So 1/21/21. And 7th period. Okay. So, starting out, solutions to a quadratic equation. Okay, do y'all remember what kind of graph we get whenever we graph a quadratic equation from Algebra 1? Do you remember what a quadratic produces? I'll give you a hint. It's a kind of a U-shaped graph. Do you remember what we call those? I know my brother covers it because we were talking about it last night. So I know he covers it at Chaffin. And I'm pretty sure that they cover it at Ramsey too. If we graph a quadratic equation, we get a parabola. Okay? Anytime we graph a quadratic, we should get a parabola. Okay, so to fill in these notes, the solutions to a quadratic equation are the points at which the function intersects the x-axis. Okay? So I'm looking for the places where the graph will cross the x-axis. The solutions are also referred to as, okay, so I'm going to tell you what my answers are for this. Sometimes we call them the zeros, because y equals 0 at the x-axis, right? So if I'm looking for where it crosses the x-axis, I'm looking for where y equals 0. Sometimes we call these roots, because we can take the square root of some of the equations to find the factor. Or we can also call this the x-intercepts. Okay, Ms. Stern, did Mr. Hotz fill it in any differently than that? Or did he have any other names for those? I was kind of curious about that because when I was looking at it, I was like, well, these are the answers I would give. But okay, so, you know, there are a couple of other names that we can use too, but they're not as commonly used, so. Okay, so here's the thing. If I'm going to get two solutions, then my graph is going to cross the x-axis in two places. And I've just been putting one example. But I'd have a parabola or a U-shaped graph that looks like that if I have two solutions. It's going to cross the x-axis in two places. Now, here's the thing. My parabola doesn't have to open up. If I have a leading coefficient that's negative, it could open down, okay? And that would be fine. I would still have two solutions, okay? If I have one solution, then the vertex of the parabola, or the lowest point, or if it's upside down, the highest point, touches the x-axis in one place. Now, here's the thing. When we have one solution, we could still factor that equation. We are just using that one solution 2 times, okay? So, anytime we have one solution, that one solution has actually been used twice to form the equation, okay? Now, to have no real solutions, my graph would either be completely above the x-axis or it could be completely below. And either one or the other. But it's not crossing the x-axis. Okay, so let me take it just a step further. If there's no real solutions, but there's either two solutions or there was one solution that was used 2 times. If there's no real solutions, there still has to be 2 of some other kind of solution. What would they be? If they're not real, then they are what? What are they? If they're not real, what kind of solutions are they? Huh? If they're not real, then they are, we talked about it last semester. I heard it, yes. Imaginary. Imaginary solutions. There's 2 imaginary solutions. Remember when we took the square root of negative numbers? And that created imaginary numbers? So, if I have a parabola that doesn't cross the x-axis, then I end up with 2 imaginary numbers as the solutions. Because somehow I'm taking a square root of a negative number. I'm just going to kind of leave that hanging there for now, okay? We'll get deeper into that later, but yeah, this ties us back to those imaginary numbers. And remember, some people said, oh, is there any real use for these? I said, well, you can use them some in electrical engineering, but there's a purpose for why we talk about them in Algebra 2, and it ties back to this, that sometimes we have 2 solutions that just, they're not real, they're imaginary. Okay, so I'll tell you what, here's kind of the attack that we took on this, okay? And I'll tell you what, I'm going to stop my